Hello, welcome to today's webinar, How to Collect More and Move Less Using GNSS, GIS Apps, and Laser Rangefinders, brought to you by GPS World Magazine and our sponsor of the event, LaserTech. Since 1985, LaserTech has been helping solve problems by creating laser-based speed and distance measurement instruments, leading the industry in the design and manufacturing of innovative solutions. Their experience developing solutions worldwide gives us the experience to work with you and your applications. I'm Mackenzie Shoemaker from North Coast Media, content marketing producer for GPS World, and I'll be the moderator for today's event. Before we get started, I wanted to let you know that today's webinar will be recorded. You are currently in a listen-only mode. A recording of this webinar will be posted to gpsworld.com/webinars and will also be emailed to you tomorrow. At this time, I'd like to acquaint you with the ways you can participate during today's presentation. Please notice the Q&A panel at the left-hand side of your console. If you have a question, type it into the panel's text box, then click Submit to place your question in queue. We encourage you to ask and enter any questions you may have for our speakers during the presentation. We will address these questions at the end of the presentation during the Q&A portion. Questions submitted during registration have already gone to our panelists and may be covered during the presentation. If you experience any technical difficulties during today's event, you may use the same Q&A panel on your screen to submit your issue, and technical support specialists Marie Emmerich or Ellen Wagner will personally assist you. You may learn more about our speakers by viewing their photo, bio, and email address in the panel located on the upper left-hand side of your console. If you are logged into your social media accounts, you can share the webinar's title, description, and URL with your friends or colleagues using the Share This widget you'll see on your screen. Today, we will be hearing from Derek, Senior Product Manager for LaserTech. Derek has been working in the professional management and mapping industry for the last 23 years. He helps to create a safer world by listening to customers and market with understanding their pain points to develop new product solutions focusing on worker safety. We will also be hearing from Nicholas, the GIS Solutions Director for Bad Elf. Nick is the GIS Solutions Director for Bad Elf at GNSS Technologies Company. Additionally, he is also a faculty member and instructor at Arizona State University. And lastly, from Steve, who is the Applications Training Specialist for LaserTech. Steve is a true pioneer in product development, marketing, sales, service, and support at LTI and has been doing it for over 25 years. At this time, I'll turn the presentation over to Derek. Derek, take it away.
Well, thanks, Mackenzie. I really appreciate it, and the GPS World team. Also, I want to thank Steve and Nick jumping on this webinar today to talk about these subjects we've got going on. So today we're going to talk about using laser rangefinders with the Bad Elf GNSS receivers, smart devices, and also their Flex app and the Esri Field Mapping app. Basically, we're going to talk about using laser rangefinders to collect remote positions, what we call laser offset workflows. We're going to go through these different workflows using lasers, also talk about just the different data collection workflows that the field crews have today to collect assets. So we're going to run through this. The team is going to jump in any time to discuss utilizing these devices and how you can collect remote positions with laser rangefinders and GNSS devices. A little more about LaserTech. We've actually rebranded. We were LaserTech Inc., Laser Technology Inc. Sorry about that. We've been that for a lot of years, but we rebranded 2 years ago. Now we're just down to LaserTech with a new logo you see down on the right. But it's the same team, same everybody there, same two guys that started the company 35 years ago are there today. We are in Denver, Colorado, where we design, manufacture, and distribute these laser rangefinders. We've got service centers across the world, here in Denver, Ireland, Asia, etc. So also we work through a very extensive dealer network across the world, working with our partners, putting laser rangefinders together with the appropriate devices, apps, and everything else needed to collect different objects in the field. So I'm going to turn it over to Nick. He's going to talk a little bit more about Bad Elf.
I appreciate that, Derek. Hopefully everybody can hear me. If you've not heard of Bad Elf, I appreciate you spending a few minutes with us today watching this webinar. Bad Elf, we are a 12-year-old, approximately, GNSS company. We started with our first device being a plug-in GPS that went into an iPod. So if you can remember the iPod technology, originally Bad Elf, we provide positioning systems and solutions to the aviation and marine industries. In the last 5 to 6 years, however, we've segued and transitioned more and more into the mapping and geospatial industries, primarily in GIS and land surveying. We have several different types of GPS/GNSS devices, depending on what your budget may be, what type of accuracy you need to achieve for your project. We like to have a little bit of fun at Bad Elf, as you can see by our logo and name. Again, we really appreciate you coming today and watching this webinar, and hopefully everybody will learn something. I'm definitely excited to be working with Derek and Steve today. So if you have any other questions or want to learn more about Bad Elf, I'll just throw this out there. You can go to bad-elf.com. There's going to be contact information throughout the presentation. You can also follow us on all of the major social media platforms like LinkedIn and Instagram, Twitter, and Facebook. Okay, so that is a little bit about Bad Elf. I'm going to go ahead and pass it back.
Yeah, hey, thanks, Nick. I really appreciate it. Again, glad you're here today to talk about Bad Elf and just about your experience utilizing GNSS receivers and lasers. A little bit more about, or just kind of deeper dive, what professional laser rangefinders are. You might not know, a lot of people hear about laser rangefinders and you can think about the golf or hunt market. What we do is a little bit better than that. What we do, we've got the laser sensor. That laser sensor measures distances. There's no need to have a reflector or a prism to get the measurements to the remote or to the object. Basically line of sight, take a measurement, pulse technology, reflectorless technology, get that measurement distance to the object. And then in all our lasers, what we incorporate is a tilt sensor or accelerometer sensor. This measures forces of gravity, so it knows where the unit is tilted from 0. You can see there to plus or minus 90 degrees. Used for slope percent, also elevation, and also height measurements, utilizing the tilt sensor. And then another laser rangefinder we have is the compass sensor. And the compass sensor measures magnetic north. Also, you're able to put in a declination in there, so you can also measure true north. But we measure with that compass sensor, measures magnetic north to give you your azimuth measurements. What does that look like? Kind of just with diagrams here. Make sure you understand, like the laser. What we do is slope distance, SD. You're going to see that in a couple other diagrams coming up throughout the presentation. Or slope distance, also some people refer to it as line of sight. So you get the first measurement where you get that slope distance measurement with using the laser sensor. The tilt sensor, or inclination, degree of inclination, get measured plus or minus 90 degrees. And then when we incorporate or integrate the compass sensor, you get the azimuth, degree of azimuth. So you see the two different diagrams here. And once those values are measured, the unit will automatically calculate a VD, or vertical distance, and also an HD, horizontal distance. Again, with the press of the fire button, you're able to, the unit measures all these values within a third of a second, displays that throughout the viewfinder, and then outputs all these values through a serial string that an app that can capture all these different values. Not only just taking measurements, just single measurements to objects or the values, we have different onboard routines. But the first one here I'm going to talk about, the upper left, is measuring a height or clearance. So we call this the three-point height measurement routine. So your first measurement, shot 1, is a slope distance and inclination to the object. and then we calculate that horizontal distance. So you can measure it anywhere on that object. You can measure the top of it, the base of it. We're still going to calculate that horizontal distance. And the next two measurements are an inclination only. No distance measurements are taken at this point. So you do a shot 2, an inclination to the top of that light pole, shot 3 to the base of it, then the unit automatically sequences to the height value. It'll display the height value and then output that also. So if you need to capture height values of an asset, a remote asset that we're going to be talking about, you can do that very easily here with the height routine. The other onboard routines we call is a missing line routine. With our, you can do a 2D slope, the diagram on the right. This requires 2 measurements, one measurement to the top, or base, I mean, and then the top, and then we can measure that slope. I'm missing a couple different dotted lines in this diagram, but if I backed up one, you'd be able to see that vertical distance also from shot 1 to shot 2. It calculates, and then from shot 1 to shot 2, we also calculate that horizontal distance. Then the third is that when we integrate the compass sensor, we can measure span, or distance between 2 remote objects. So you can stand in a safe location, measure to the right light pole, measure the left light pole, and then the unit will calculate all those different values. You can get the drop between shot 1 and shot 2, or the rise, etc., from those 2 different shots. And then those values, those calculations, also output through a serial port and also Bluetooth communication. The different models we've got are the TruePulse 200X. TruePulse 200X measures slope distance and also inclination. And you can see the different you can see the accuracies we have here. The range accuracies plus or minus 1.5 inches, and then also the inclination accuracy. So we can again take a measurement to the object, measures the slope distance, inclination, and it calculates that vertical distance and horizontal distance. When we integrate the compass into the laser rangefinders, we call that the TruePulse 360R model. The range accuracy on this unit is a little different from the 200X. Our 200X is the most accurate pulse technology laser rangefinder we have. This one here is plus or minus 8 inches in the range accuracy. But the big thing you want to look at once we integrate the compass is that azimuth accuracy. You can see that it's plus or minus 5 degrees, 0.5 degrees. And with that, and there's no pitch or roll limitations. So even if you're tilting it up, 45 degrees or negative 45 degrees, or even on the left hand, or a little kind of give it a little roll, you can still maintain that azimuth accuracy. So that's what's really important, especially in the field, because nothing is always level in the field. You're taking measurements to the top and the bottom, anything like that. So, but you always maintain that azimuth accuracy. A device I did not have in an earlier diagram, we also make a device called the True Angle. What this True Angle would do is measure horizontal angles, just kind of like similar to azimuth measurements, but this is horizontal angles. So with the encoder that we have here, it's unaffected by local magnetic interferences. The compass can be affected by magnetic interferences, so that can affect the accuracy of that. You've got to work around a lot of vehicles or next to buildings and everything like that. This is a device to use, and you're still able to get those 3D measurements. You're still able to get that slope distance, inclination, and a horizontal angle. This is kind of like a little like where you've got to set a 0 with the True Angle. You set you're going to say this north is 0 here, or this area is 0, and from there it turns the turned angles, the horizontal angles from that. You can see the accuracies you get of 1 degree, and 0.05 degrees when it's tripod mounted. And with those different devices and everything like that, you start to collect all the different assets you need in the field. And Steve's going to talk about just all the different data collection workflows we have or that are out there utilizing different devices.
Thanks, Derek. Yeah, I'll start off talking about a couple of traditional methods, alternate methods that some of our attendees might be using right now. The first here is just using GNSS alone to do the data collection. And It's a great technology. You've got to have a nice open sky to get your accurate data and so forth. And but here's the basic steps are you've got to walk up to the feature. You've got to get that antenna over the feature that you want to map somehow. So that's one of the first critical things. And then get everything going. Wait for your signal. Tap in your notes or data that you're collecting about that asset. Verify everything's good, and then walk on to the next feature, and then repeat all those steps. So as long as you've got clear line of sight to the sky, a nice open sky, you can collect the data in this manner, as long as you've got access to the features. Another technology that's being used a lot, more and more for doing GIS data collection are drones, and they are definitely a good technology and has some great applications. The workflow that you've got to follow for them, you've got to do your pre-flight inspection. You make sure you're not, flying over any private property or anything like that. Ensure all your liabilities are covered that way. You've got to put in your ground survey control points so you can get everything referenced later on. And then go ahead and launch the craft and operate your flight plan, get it back down safely, and then hope you've got everything captured that you need when you leave the field. So a couple of alternate workflows. So let's talk about the laser data collection workflows. Derek mentioned our 360 model, and that would be able to do our range azimuth mapping method, we call it. So you're measuring distance and azimuth to the feature. So it's one of the easiest ways to do it with just a single shot. You've got to have line of sight to the feature, but you just take that single shot, the 360 model, and you can position objects. So the basic workflow, you stand on a known point, you measure that distance, inclination, and azimuth to the target, so you can collect a 3D position if you need to, and then the coordinates are calculated. So just a simple diagram there to follow along with. Next, utilizes just the distance capability. Distance and inclination capability of the laser. So you could use the 200X model here or the 360R. But it's definitely the most accurate way to position objects with our rangefinders. It takes out all compass error that you might have or anything else in a horizontal angle and just uses those ranges. Derek mentioned, couple inch accuracy on that TruePulse 200X. So you can get pretty tight with this method. So basic workflow, again, you stand on a known point, measure distance and inclination to the target. Again, if you want to get a good Z coordinate for it, you can use that inclination value. And then you occupy another known point in the vicinity. So you move off to another known point and measure distance back to the same target. And you just tell the software kind of which side of that line in between the two known points you're on, and you can plot the point. So there's good geometry you want to follow in this method to get your best accuracy. You don't want your two known points you're occupying to be too close or too far apart. There's kind of a sweet spot there, but it's a great method. So alternatively, with actually one of our other apps, you can kind of reverse this, and you can set up two targets on known points, and then go occupy the feature you want to map, and take your shots back that way. So kind of reverse it around. The first workflow there is best when using GPS. You've got that antenna, to give you your known points and everything. So, and then the last method we'll talk about for the lasers here is the range angle. Derek mentioned that True Angle product that we have, which is an optical encoder, so completely immune from any interference of magnetic field and everything. You're just not using that. So, just like a regular optical total station or something. So you pair it with our most accurate 200x laser, and you've got a real accurate system that can take advantage of that kind of single shot positioning capability. However, as you can see here in the workflow, you set up on that known location, you do have to take one shot one time to a reference point. So you can kind of reference that horizontal angle on a known azimuth. So software knows the actual target azimuth to use to calculate the coordinates. So you just occupy that point, take your one shot to the known reference, and then you can start banging out points, remote targets, and calculating those coordinates using now angle instead of azimuth. But there's kind of an azimuth being calculated behind the scenes there. So those are the data collection methods, and Derek's going to take it back over now and talk about some of the challenges you find out there.
Right, Steve. With all those different workflows, like all field crews know, you run into all different types of challenges in the field to capture the data needed. You know, a lot of that it might have to be just with one of our big ones we see is like manhole covers or water valves in the middle of the street. Just how do you take the receiver there and actually occupy that point? Close the street, or like I'll use how old I am. Use the old Frogger, run out there and play Frogger trying to collect the data, or just a lot of collection of trees or canopy. That might be some challenges. Might affect the GNSS signals or degrade the GNSS signal, not to be as accurate within in certain canopies or urban canopies. Could be down an alleyway. Another big one we see is just always about private property or just getting behind a fence. I think in today's world, we know a lot of people are working from home. The field crews have challenges themselves, being out there, walking on the sidewalk, need to get access to private property, and of course you've got somebody walking out and asking what you're doing. So those are always difficult things to handle for the public and also for field crews. And then also a lot of multiple assets, walking up to each one. Steve talked about this with the first workflow there, walking up and making sure you're walking to every asset to capture that with the receivers, and then also maybe even jumping in trenches and getting back out of trenches. So those are different challenges I know you guys have all run into, that the field crews run into, and so we're going to be talking about different ways to try to eliminate some of these challenges. Not only those type of challenges, but there's environmental conditions that we have to work with. Everybody works across the world, different weather patterns, everything like that. You've got extreme heat, rain, etc. So you've got a lot of different things you've got to work with all the different devices you have in there. And then also, vegetation, fences, just the visual obstructions might come in the way. I've kind of touched base already about dangerous areas, highways, the Doberman effect, also kind of crossing that fence. Who wants to be the mailman there? So those are big things that you got. You got a lot of different environmental conditions you run into. And I know Nick, he's before Bad Elf, he's talked about it before. He did a lot of work utilizing all these different devices, collecting data in previous work. So he's going to talk about a few things that he's run into. So I'll turn it over to you, Nick.
Thanks, Eric. So just to give a little bit of a background and context of who I am, and maybe to give some street cred to what I'm about to talk about. For the past 15 plus years, I have been a complete geospatial nut. And what I mean by that is I literally will say that I eat, sleep, dream geospatial. To the point that in graduate school, I met my wife, and she also is a geospatial professional. When we met, it had developed quickly, and I even proposed to her at a ESRI users conference right before we gave a presentation in front of about 1,000 people on lasers. I put this into context just to solidify that I'm not talking to you right now coming from a manufacturer's perspective. I'm coming as somebody that has been doing geospatial work for quite some time. Originally, I got into the field doing archaeology and I loved archaeology, but I loved the mapping side of it so much that I actually transitioned from being an archaeologist, a professional archaeologist, to being a field technician doing land surveying and mapping. What you're going to see here over the next few slides is some of my experiences from archaeology. I worked quite a bit in the arborist, environmental tree sector, also getting my certified arborist. I worked for several years as a director at a utilities company, and I ran a department of about 45 geospatial professionals that did the mapping of infrastructure, and I'll show you. Additionally, I've been associated with academia. During this whole time, I spent about 10 years in college getting my PhD in geography, behavioral geography, and to the point of which I'm at now, working for a manufacturer, Bad Elf, helping promote, proselytize, and really train high-end geospatial professionals with GNSS equipment or global navigation satellite systems. So this first slide I've got here, there is a little elf sitting there, but this was before my Bad Elf days. My wife and I actually had the opportunity to work with UNC Chapel Hill College back east and the University of, I'm trying to remember the actual university in the Yucatan. It's slipping my mind at the moment. It'll come to me in just a second. But we were invited to come down to the Yucatan Peninsula. If you're familiar, this is a place in Mexico where the indigenous Maya are traditionally from. This is also where you will find the famous temples like Chichen Itza. This is also off the coast where they suspect that the asteroid hit the Earth a long time ago and potentially killed off the dinosaurs. To give context, this is a very jungly area. And when I say that, you have thick canopies of forest, rainforest at that, that you can't see, 5 meters in front of you. Additionally, this area is filled with limestone caverns, cenotes, and these cenotes are actually one of the things that we went down to map. Partially, we were mapping 3 Maya indigenous villages that had Catholic buildings put in 500 years ago, around 500, 600 AD. But then we wanted to correlate these villages to their water sources, which were cenotes. And this is where the LTI rangefinder came in. So this was one of my first experiences outside of playing around a golf that I was able to use a rangefinder. At the time, LaserTech actually had donated and let me take it down there free of charge, pro bono, to support this academic endeavor. I actually utilized the rangefinder quite a bit in a quote-unquote poor man's total station where I needed to collect assets that were in dense canopy, and the GPS equipment we have wouldn't work in the canopy. And so I utilized the LTI rangefinder to collect those jungle assets. I think even more cool than that is I used the rangefinder to measure the depths of the wells in these villages. And so I actually took shot down wells and insides of these caves, and we were able to do some subterranean mapping and then correlate water levels to it. So it was a really neat way of showing an extremely kind of harsh environment where not one technology was going to work, where having an LTI integrated into our solution was really a benefit. Fast forward a couple of years, I worked in Phoenix. I mentioned a telecommunications company. And at that company, we utilized, coincidentally, we had Bad Elf GPS devices, the GNSS surveyors. You can see it, a little picture there. It's a little yellow-looking hockey puck device. And we Bluetooth connected them with iPads, and I had about 6 field technicians outfitted with LTI rangefinders and that tablet and GPS. We were using Esri at the time. It was Collector. We set up a custom ArcGIS online map with several forms, and you can see we were collecting utility pole information specifically for telecom. And so we had to go in and map the different assets on the pole. Obviously, getting to these assets were difficult. Number one, Phoenix is littered with square concrete block walled areas. And so getting into people's backyards could be very difficult and time consuming. I'll tell you what, you know how you kill a budget is you have to go knock on the door and ask for permission to survey the pole in somebody's backyard. That person's not there. You can't collect the data. That forces a remobilization of going back out to the site. Well, if you have a LTI rangefinder attached to a GNSS device, you can do all your measurements remotely and not have to do all of that remobilization. Not to mention, if you've ever seen a rat's nest of power lines in telecommunications, usually telecom's the bottom wire, but they get really hairy. And you don't want to be sticking things up there or going up there personally. It can be very dangerous. And so having a rangefinder that was able to report these distances back to our custom app was really time efficient. And what was neat is we were even able to export out with a Python code all of these measurements into an AutoCAD document that was populated with the measurements collected by the rangefinder. Last but not least, is we've got this kind of fun little Bad Elf graphic, and I wrote at the top, hard to capture and overhead obstruction. I worked at a landscape architecture and environmental design firm right when I had gotten to the Phoenix area, and we luckily, at the time, I was 24 years old, we had the APS Arizona Power contract to walk all of the transmission lines in Arizona. For a year and a half, I worked 8 days on, 6 days off, and I mapped out thousands of miles of KV line, some KV lines up to the 500 and down to, you know, the smaller lines. At the time, we were doing it for archaeological purposes, and so we were looking for sites underneath these sags. But when we were there, we were required to do a lot of the mapping of the towers. If you've ever stood under a 500 kV line, you literally buzz with excitement, and that's that electromagnetic interference there, Steve and Derek were talking about before, which really can throw a havoc to your GPS. Additionally, these things can cause what's called a multipath error. So when your GPS device is listening to satellites, that radio signal being transmitted from space can actually bounce off this metal architecture or infrastructure rather, and cause problems. One of the things that we had to do is map what they called raptor nests. And raptor nests were basically bird of prey eagles and falcons and things, they would make nests in these large transmission lines. And at the time, we didn't have a rangefinder. It was a totally awful situation, and we weren't able to really confidently map it well. We had to take a lot of pictures. And I just think back to when I was walking those power lines day after day, if I had a rangefinder, how much easier that would have made some of those pieces of information we had to collect for the power service. One last quick thing, and I've probably gone over my allotted time. I'm sorry, I'm a little bit of a talker, but I just really want to hit home on how powerful a rangefinder can be as a tool in the tool belt. There are lots of geospatial technologies out there. We've mentioned a few of them, GNSS, you know, the GPS stuff like Bad Elf makes. We mentioned drones. There are ground penetrating radar systems and utility locating systems and LiDAR systems and aerial stuff and satellite imagery. And the reality is, in my experience in the last decade and a half, to really be a good field data collector and to be very confident, be able to collect all the different data in the different circumstances, you really need to have all of the tools at your disposal. And rangefinders are one of those things that you can pull out of your pocket at any moment if you've got a site that, you know, deems that necessary, and it really can augment in, you know, a really good solution into what you're doing. Because again, just imagine if I had to collect something and I can't get to it, or it's dangerous to get to it, and I had to remobilize to get there. Anybody that's ever priced out a project and done job costing knows that the moment you have to revisit a site, it's game over. Not to mention, you know, the dog effect or the mailman effect, as mentioned earlier, right? The injury that could happen, especially in very dangerous environments. And that's what I want to end with. Coincidentally, last night on the way home, driving home from work, I passed an accident at an intersection, and it wasn't good, and it was very bad. There were lots of police officers there. It looked to be a motorcycle and a truck that made contact. After I had gotten through the initial shock of what I was looking at, the geospatial nerd in me came out, and I immediately realized that the police officers were utilizing a true angle LTI on a tripod on top of a GDAC point that I had identified. I could see from the car. They also had a large Matrice drone in the background, and they were taking lots of photos. And it really hit home to me again that here's another example of a not so peachy keen situation, but having traffic and power lines and having to have them utmost accuracy because the police officers were dealing with a fatality. And it reminded me as well that we have Bad Elf customers across the United States that do crime scene investigations exactly like this with LTIs and our Bad Elf Flex. So I'll leave you at that when you've got the right tool, you can really bridge the gap in terms of geospatial data collection. And when you look at rangefinders, it's one heck of a tool. Okay, so I talked too long. Derek, I'm going to pass it back to you.
Hey, Nick, I really appreciate that. You hit the nail on the head with a lot of that you talked about, just with having there's not one right tool, right, to use to do all this data collection. And that's what we're trying to get to, is talking about utilizing what you have already. So a lot of, field crews have GNSS devices, integrating a laser rangefinder into that workflow that we've been talking about. Talked about different devices, different workflows, but when we integrate the laser rangefinder with GNSS, what we call that laser offset mapping. You touched a little bit about that. Basically, just kind of breaking it down is you occupy a point in a safe location, get to your coordinates, download that into the app, and then with the laser rangefinder, you measure over to the object, and with all the different values that I've talked about earlier, the app will actually calculate that remote GNS coordinates based on your location, based on all the values the laser rangefinder gives you, and then that's that point. So you can stand in one location, map safely, and get a lot of different things, different assets from one location. With those workflows, Steve touched about that with just the laser workflow, but now we're going to incorporate the GNS with the laser itself too, in that laser offset mode. Steve talked about just using the lasers in those earlier slides about occupying a known point. Well, now that GNSS device gives you your known point. You don't have to find any devices or just say this is 000 or 00. So the first one is distance azimuth or one shot. We've heard about that. So it's utilizing the TruePulse 360 with the GNS device and the app. It's good for capturing, good for densely populated features. It's fast, highly portable, so you stand in one location and capture a lot of objects, and then move quickly to the next location, and then start all over again. So it's a one-shot laser offset workflow. That's really easy to do with the TruePulse 360 and your GNSS device. The next one, add more onto what Steve talked about, just the laser workflow, is again utilize the GNSS with what we call the distance or range. We can run range triangulation, all different ways of hearing, different ways to talk about this mapping method. It requires utilizing two control points. So with the control points, instead of like a known control point or having targets, as you're going to use your device and get control point 1, capture that position, use the TruePulse 200X because you're doing the distance and inclination, shoot to the remote object that captures that first position, move to control point 2. You need to have good geometry like Steve talked about. Capture that GPS location, shoot to the object, and the app does all the calculations from there. That's it. Does that range triangulation. It's good for features that are more spread out. If it's dense, it's kind of hard. You got to do two control points. So that's quite a bit. But we talked about how the accuracy is utilized in this type of a workflow with just the 200X. It's not affected by magnetic interferences or have any other angles there. It's just the laser accuracy of the 200X taking measurements to the object. And the third workflow we did talk about, or Steve talked about, is distance angle, utilizing the true angle. It's like a total station workflow. What you've got to do is set a backsite. So with this workflow, you set up your backsite with the GNSS device. You set that position up. Then you move to your control point. When you're at that control point, you shoot back to the backsite, so that now the app is gets a known or an azimuth value based on your control point and the backsite, taking that measurement. And then from there, you're able to now measure all different assets, different areas. So you can take one shots out to the manholes and be able to capture that remote position. So good for high density. Also, if you're in the areas where it might be a lot of vehicles or up in buildings or down those urban canyons and stuff like that, this unit's not affected by magnetic surroundings. So those different workflows, of course, each one of them, we got different laser accuracies, you have different GNSS, different accuracies, but the biggest question that always comes up, and I know Steve we talk about this all the time, is what is that offset position accuracy?
Right, Derek. That's critical. And one thing we haven't talked about is adding. When you do take a laser shot to position something, you can't forget about that possible error you're putting in there, and making sure you include that in your error budget when you're looking at your GPS receiver accuracy also. So if you've got a job that requires sub-meter accuracy for the points, you've got to make sure if you're going to use a laser that your GPS accuracy is much better than that, so there's room, so to speak, for a little bit of error from the laser. So that's the point we're trying to drive home here, is make sure that you think about that. Some of the applications that have been written even work it in there for you and notify the user, but just good to wrap your head around the concept of making sure you've got both of them included in your budget. So as I mentioned earlier, you can see at the top here, those range methods are super accurate. And what we've used here are typical position accuracies. The accuracies Derek mentioned earlier, particularly in distance, are kind of worst case accuracies. And what we've done here is use more typical type positioning accuracies. So the true pulses, for example, the 360R, that's typically going to be within a half a foot distance accuracy, oftentimes much better than that, a couple inches even. But, if we use that 6-inch guideline, you take a couple of shots with it, you're going to stay in that type of realm for your position accuracy. Another thing to note here is that it doesn't depend on the distance that the feature is away. So you get the same accuracy with the range positioning to a target 150 feet away as you do one 300 feet away. You don't lose any accuracy there in distance. Like you do with these other methods below here, the range azimuth and range angle, if you think about that compass or that angle accuracy, it's going to expand over distance, right? It's going to be less at a shorter distance and greater at a longer distance. So that's what you see reflected in these numbers here. But still, you look at these numbers and, the worst case type accuracies are a half a meter here with some of these methods. And, as long as you're using a nice decimeter, maybe 20 centimeter GPS, you can certainly still stay well within a sub-meter type spec. So you just want to look at it. Look at your final spec the customer wants you to deliver, and then you can kind of pick out a method that'll get you the best results combined with your GPS accuracy. So we wanted to mention that we have a couple of white papers on these subjects. One that goes over this, using GPS and 360 model, and then gets into those accuracies I just mentioned. We also have another one on height accuracies. Height is an attribute that people want to measure a lot with our lasers, so we've got a whole paper on that and those accuracies and what to expect out of our different models for that value. So you can find those on our website. So we are going to go back over to Nick now, talk a little bit about the integration.
Great, thank you, Steve. So just to throw this out again, Bad Elf, we create GNSS, or Global Navigation Satellite System devices. That's a fancy way to say that we create a GPS that also tracks GLONASS, BeiDou, and Galileo, all 4 quad constellations of satellites. We have been a partner with LaserTech for quite some time now. I'd love to just kind of say that we are a match made in heaven, and our devices work really, really well, and we have quite a few customers using the Bad Elf positioning devices with the LTI rangefinders to great success. What I'd like to talk about today in terms of Bad Elf's GNSS is our flagship product called the Bad Elf Flex. Yes, this is a GPS device or GNSS device. If it looks a little different, as with our name, we like to be a little different. And so you can see here we have 4 major buzzwords: accurate, affordable, and versatile. So the Bad Elf Flex has several modes of operating. Steve just mentioned that if you were in the 20 centimeter range with a rangefinder, you could easily, with a rangefinder's accuracy, and keeping in mind you've got to take the accuracy from the Bad Elf Flex and you've got to add it to the accuracy threshold of the LTI rangefinder. And once you put those together, that's going to be your estimated accuracy. And so if you have a 1 meter tolerance, you could use the Flex in actually several modes. The standard Flex out of the gate, and this is all the same hardware, and so we can switch it digitally underneath the covers, but the standard Flex is going to get you 30 to 60 centimeters or 1 to 2 feet of accuracy in most places of the world by just turning it on, Bluetooth connecting it with your phone or tablet, and you're off to the races. If you need more accuracy than that, we have a pay-to-play token option where you can use a token per day and get a 24-hour countdown, which then initializes what we call extreme accuracy mode. If you are a mapper that is out in the field all the time, extreme accuracy mode can be unlocked for the perpetuity of the device. And when you have extreme accuracy mode unlocked, you have the ability to connect in with an RTK network. That RTK network can be a VRS network, so provided maybe by the state or third-party provider, or we can do what's called base rover. And so we can actually have one Flex talking to a second Flex, and as long as the second Flex has the rangefinder attached to it, you can now use them all in tandem together. And to throw it out there, in extreme accuracy mode, it is a fully survey grade, fully engineering grade device, getting into the centimeter or better accuracy. So if you were using the Bad Elf Flex Extreme with a rangefinder from LTI, you can expect some very high accuracies. It is also affordable. So one of the things that Bad Elf does is we've flipped the business model on its head a little bit. And while we have some highly trusted resellers that we work with hand in hand, a lot of our sales come through online sales. And so you can purchase our equipment from our website. And so what we've been able to do is give back some of that margin to our customers. And so you'll notice after doing your due diligence that the Bad Elf Flex is extremely affordable. We have different options for accuracy. And so you can kind of choose what you need. And we also have an integrated network option for the RTK called Point One Navigation, which is extremely affordable in the marketplace. Last but not least, we like to say we are versatile or easily adaptable to a various amount of activities, and this is exactly the connection with LTI, and additionally with, say, ESRI, the GIS software, ArcMap. But even so, Bad Elf, we are versatile in terms of we can connect to an Android device, an iOS device, a Windows device, and most of the apps that work on those devices. The Bad Elf Flex, even though it looks a little different than, say, your typical choker ring disc antenna, because we use a helical antenna, it does have a 5/8 inch typical survey mount on the bottom to connect to a pole. There's an adapter for a 5/8 inch. You can even attach a 5/8 inch adapter into the back of the device. We have buttons and a screen, which is a little bit different than a lot of GNSS solutions on the market. And that's so you can do some standalone data collection with those buttons and not need to connect to a a tablet or a phone. The other thing is the screen is like a dashboard. Imagine driving your car without a dashboard or your dash. You wouldn't know how fast you're going, what your oil life was, et cetera. And so having that screen on there is a really good way to know that your Bad Elf Flex is operating correctly, so that when you're taking your offset measurements, it's doing exactly what you would expect it to do. Bad Elf integration, and so we are fully integrated with LTI's rangefinders, and it's something we're very proud about. And so you can go on the Android Play Store or the iOS App Store, and you can download the Bad Elf Flex app for free. And the Bad Elf Flex app will actually Bluetooth connect with the LTI rangefinder directly. And so what's pretty neat there is we are inclusive in terms of the operating systems that you can connect with. This is a concept called Bring Your Own Device, BYOD. And so you basically bring your own phone or tablet and connect it to your devices like the rangefinder and the Bad Elf Flex. When I say we are integrated, again, I'm going to hit home that via Bluetooth or a hardwire connection, the Flex directly talks with the LTI rangefinder. One of the things that we have done design-wise is utilized what we call a checklist format. I mentioned earlier that Bad Elf was originally heavy in the aviation industry. Some of our owners and founders were pilots, in fact. And if you've ever done any aviation, or perhaps you're an FAA 107 pilot, you'll know that they employ checklists. It's an easy way to get through a workflow and know that you're doing things correctly. And so you can see on the screen there that on the left, you've got all kind of your fix information. You've got an RTK, you're getting a centimeter of accuracy. You've got a lot of satellites, et cetera. But on the right side, you can see that we're connected directly to the True Pulse. And you follow those on-screen checklists, and you click one after another. It's very easy to follow along synchronously because it's just a checklist. And if you don't get a green check, you've got a problem. And so you can see there for an example, capture control point. It may say tilt check, accuracy check, capture location. And so it will even warn you if things seem to be out of spec. And so again, we are very proud about this. We've even integrated in the geoidal model. So if you're using geoid 18 or geoid 12B, depending to get orthometric height, that we are using the orthometric height calculations with the offset measurements being produced by the rangefinder. I also mentioned that we're one of the few people, GNSS providers in the marketplace, that utilize LTI's height measurement. So we don't just do offset horizontal. Bad Elf Flex in our app actually will utilize height measurements as well, and so we're pretty proud about that. Last but not least, I want to just mention that we are also business partners with Esri, ESRI, same with LTI, and so we're a big, happy family. And we have integrated the Bad Elf Flex directly with the Field Maps team, and so we're very fond of the Esri team in Redlands, and they have our devices, and we have a direct connection. And so when you pair our device to your phone or tablet and you start up Field Maps and you just make sure that you've got some settings put in there for the device, everything is going to work seamlessly. But what's even more impressive is we're one of just a few brands that have the offset measurements directly integrated into Field Maps as well. So if you are an Esri shop and you're doing GIS mapping and you want to do offsets, you can actually click the three little dots. If you look on the left side of that picture where it says Bad Elf _point_ name, those three dots, you can navigate to an offset button where literally in tandem you can have the Bad Elf Flex app in the background and the Esri app, and it will pass the data and the offset measurements seamlessly between all of the apps, getting your offset laser rangefinder data right into your ArcGIS online maps. And again, that is really, really powerful. One of the examples I showed earlier did not have the ability to streamline this, and some of that information was manually clicked into the app. And so having this be able to pass the information natively to Esri's Field Maps is quite powerful. Okay, so that's kind of a little bit about Bad Elf. Again, at the end of the presentation, there'll be some contact information. If you have any questions about the GNSS side of the world, we'd love to chat with you. And with that, I am going to pass it back to Derek.
Hey, thanks, Nick. I really appreciate you running through the workflow there. And just looking at, we talked a lot about different applications. I'm not going to go through each one of these. Nick, you hit a bunch. Steve did too. So you can see how versatile this can be, which you can use these different devices to capture what's needed and what accuracies you might need for that offset position and how to be safer and everything. And just to wrap up, just measure more. One of our taglines is measure more, move less, or map more, move less, all from a safe location. That's the big thing, because nobody, out there, people aren't paying attention to everybody that's in bright yellow or bright orange anymore. They're just cruising along. So how to overcome those field challenges, we talked about that. So everything like that. And the biggest thing I think touch base is you getting out there. You want to collect as much as you can, save time, save money, get the field crew safely home. So with that, just the last part, just our contact information. Here we've got, so reach out to Steve, Nick, myself, everything like that. Really appreciate that. So at this time, I'm going to turn it over to Mackenzie and the GPS World team.
Thanks all, that was great. At this time, we're going to jump into our Q&A. My first question is, in the mapping methods, is there a guideline how far apart the two control points should be?
Yeah, a good rule of thumb, Mackenzie, is that if you are shooting, say, 50 feet to your target underneath the trees there that you need to get from your first point, move 50 feet with your GPS. Kind of try to create an equal-sided triangle there. That would be the optimum geometry.
Okay, great, thank you. My next question, how does the Bad Elf app use checklists to manage the workflow with the LTI rangefinder?
That's a great question, Mackenzie. I can take that. As I mentioned just a second ago, we integrated a checklist to force our customers and our user base to follow on-screen instructions. If you've ever dove into apps and you've jumped into screen after screen after screen and you've got to go to this setting and that setting, and it's a bear. And actually it's one of the downsides of typical GNSS data collection, that you've got to deal with these user interfaces. And so adopting an aviation approach, and I say force, but we push the user to go through the checklist, making sure that each piece is correct, so that, I mean, if you collect bad data, you're going to produce, if you're doing things badly, you're going to produce bad data. CRUD in is CRUD out. And so the checklist, by literally clicking down just what's on your screen, helps the user make sure that all of the things are set correctly, and so that when you go to shoot the laser, you are collecting the best authoritative data possibly. And it's literally just clicking through the checklist. And if you miss a piece of the checklist, it won't let you continue. Or if something is out of whack, the checklist will warn you.
Great, thank you. My next question, when it comes to distance offsets, what are the best practices? Is there a maximum distance away from the object?
Yeah, I guess that would get back to my point I made about when you're using a compass or an encoder and you get that increasing error potential over distance. That's all you'd have to keep track of. If you're using the range method, you really don't need to worry about how far you are away from the object. But if you're using one of the compass or encoder methods, just keep your measurements within a couple hundred feet if you can, as a good rule, or you can just kind of calculate out, how far away your objects can be to stay within your error budget. That's the critical thing.
Perfect, thank you. We've got time for one more question. So my last question is, does the app display all of the data/metadata to the user when collecting offset data with the LTI and Flex?
Yeah, the short answer is yes. It's reporting a lot of that information directly to you. So you can, before you save everything or before you say go to the next asset or object that you would like to collect, you can do a quick QA/QC and literally see what those distances are, as I mentioned earlier, orthometric heights, et cetera. So yes, Mackenzie, it does give you that data live.
Great, thank you all. And to all of our viewers, thank you for attending today's webinar, How to Collect More and Move Less Using GNSS, GIS Apps, and Laser Rangefinders, brought to you by GPS World Magazine and our sponsor of the event, LaserTech. If you have any additional questions for myself or for our speakers, you can reach out to us directly via the email addresses you see on this slide. The resources panel houses a PDF of today's presentation slides, which are available for download. And tomorrow, a recording of this webinar will be emailed to you and posted to gpsworld.com/webinars. Upcoming webinars from GPS World will also be posted to that page. Thank you all for attending, and we hope you'll join us for our next great webinar.